Hi guys, back with me again, Adi Kurniawan Yusuf. In this video, I would like to explain to you about Anova. What is Anova? Anova is analysis of variance. It is the statistical task that checks if there are significant difference in the average of 3 or more groups in a dataset. How does it work? It compares the variation between groups and within groups. For example, a company has 3 plans, Plan A, Plan B, and also Plan C. So Anova compares the variation between 3 plans and the dataset in each plan. To perform Anova, we will use F-test. This is the graph of F-test. As you can see that the F-test could not be negative like Z-test and T-test. It will be always positive. However, for testing the mean difference among 3 or more groups, we will use only one tail right. For conducting Anova analysis, we will use directly Spss. Let's go directly to the sample question. Zero Companies wants to compare its average sales across 3 new plants that were opened in 2023. Let's refer to them as Plan A, Plan B, and Plan C. At the 0.05 significance level, can the companies conclude there is a difference in the mean sales? Since we want to compare 3 groups, therefore we will use Anova. Let's directly use Spss to analyze the result. So this is the data that has been typed in Microsoft Excel. Plan 1, Plan 2, and also Plan 3. If you see here that Plan 1 has 5 samples, Plan 2 has 6 samples, and Plan 3 has 5 samples. So the overall sample, we have 16 samples. To perform Anova test, we have to remake the table. So the first column will be the plant sales, and then the second column will be the plant. This is the sales of the plant, and this is the plant. We can copy the first plant here, the sales, and then we put the plant is 1. And then the next one for the second plant, this one, we put this as the second plant. And then the last one, this is the third plant, sales. We put this as Plan 3. Then we will copy this data into Spss. So we open Spss first, go to variable view, and input this is the sales and also plant. The sales, yes, it is numeric and it will be scale. While for the plant, it will be numeric, number 1, 2, and 3, and it is actually nominal to represent the first plant, second plant, and also the third plant. We go to the data view. There will be 2 columns here, sales and also plant. Then we copy the data from the Microsoft Excel. We copy this data and then we paste it here. Alright, since the question is there any difference in the mean sales of 3 groups? So the hypothesis will be like this. The HO will be mu1 equal to mu2 equal to mu3. For H1, you cannot write mu1 is not equal to mu2 is not equal to mu3. Cannot. Because it means that all the mean has to be different. The opposite of all means are equal is at least one of the mean is not equal. So you can put H1 at least one of the mean of the sales is not equal. Or you can say that the mean are not all equal. One more time, the mean are not all equal. The significance level will be 5%, and the test we use is F-test and one tail right. Now let's perform Anova test in Spss. This is the step, analyze, compare means, and also one-way Anova. So actually guys, there are one-way Anova and two-ways Anova. One-way Anova, if we want to compare more than 2 groups, at least 3 groups, and considering one factor only. In this case, we only considering plant factors, one factor only. For two-ways Anova, you consider 2 factors. For example, you want to know the effect of gender at intensity training on the weight loss. We can use 2 Anova. In this video, we will only discuss about one-way ANOVA. Okay, after analyze compare means one-way ANOVA, click it. Move the variables that we want to know the difference. It is the sales, move it to the dependent list, and also the factor. This is the group. We have put the group in the plan column, right? Group 1 is plan 1, group 2 is plan 2, and group 3 is plan 3. Move it here. By the way, guys, we know the significance level is 5%, right? If it is not 5%, actually you can change the significance level here. In the option section, you can put in the confidence interval. However, if you only see from the p-value, it will not affect anything. But if in the C test and also T test you want to see from the C value and also T statistic, you need to change the confidence interval. Since our significance level is 5%, so here put it 0.95. If it is 10%, put it 0.90. Is it clear, right? So we put 0.95, then continue. Okay. This is the result. The first column will be sum of square. Here, that is between groups and within groups. As I mentioned previously, how does ANOVA works? It compares the variation between groups and also within groups. If between groups, it compares the variation between plan 1, plan 2, and also plan 3. While for within group, it compares the variation inside each group. For example, plan 1 has 5 samples, so we find the variation between these 5 samples, and so on. Sum of square between groups we can symbolize with SST. Sum of square treatment. Sum of square of within group we can symbolize with SSE or random variation. While for the total will be SS total. So SS total here will be equal to SST plus SSE. And then here that is degree of freedom. In the previous video about one sample and two sample hypothesis testing, you have learned about degree of freedom. And the formula for one sample and two sample hypothesis testing will be different. For ANOVA, it will be also different. So for between groups, the DF will be the number of groups minus 1. We have 3 groups, plan A, plan B, and also plan C. There are 3 groups, so the DF will be 2. 3 minus 1. For within group, the DF will be the number of overall samples minus the number of groups. So we have 16 overall samples, the number of group is 3, so the DF within group will be 16 minus 3, it is 13. While for the total degree of freedom is total overall sample minus 1, it means 16 minus 1, it is 15. Or you can also add 2 with 13, it will be 15. The next column is mean square. Mean square is basically used to calculate F calculation. This is the F calculation. The first mean square we call as MST. It is SST divided by the upper DF divided by 2. We can find MST. And the second one is MSE. It is SSE divided by the second DF or 13. To find the F calculation, we just divide the MST here, the upper one, with MSE, the lower one. And we can find the F will be 29.589. Since it is one tail, right? The decision rule is if the F calculation is higher than the F critical, reject HO and accept H1. However, if the F calculation is less than F critical, do not reject HO. This is the F calculation and we need to find the F critical. We can see it from the F table. You have to know that the F table varies. It depends on the significance level. For example, this is for 1% significance level. Since our significance level is 5%, so we have to use 5% F table. This is the 5% F table. There is numerator degree of freedom and also denominator degree of freedom. This is the numerator degree of freedom and this is the denominator degree of freedom. So the numerator is 2, the denominator is 13. We can find here, this is 2 and 13. So the F critical is 3.81. The F calculation here is 29 something, right? So it is more than the F critical. So the conclusion is reject its O and accept its 1. We can say that at least one of the mean is not equal. Or in other words, I can say that the mean are not all equal. However, we can also see from the p-value. We can see from the sig here. The sig here is stated less than 0.001. In some older SPSS version, sometimes it is stated 0.000. We have to compare whether the p-value is less than alpha or more than alpha. We know our significance level is 5%. It means if it is less than 0.001, we can know the detail of the significance value here. This is 0.000014. Since the significance value is less than alpha, so we have to reject its O and accept its 1. So we confirm the previous conclusion that the mean are not all equal, or at least one of the mean is not equal.